Okay, last thing we need to talk about is expected value. So expected value is basically the average, like, gain or loss for something happening. So a lot of times we do it like with money, like if you're gonna bet, on a casino at a casino, like you'd find the average amount of money you're gonna make or lose per bet or whatever. So a common problem you'll see, and we'll talk about here's the formula, but we'll talk about how to do it down here. So if we are looking at this problem here, they have kind of two different method explanations here. I use method 1. I don't love how they explain it though, so I'm just going to explain it how I want to explain it. But these are two different methods. You get the same thing either way. If you don't like my explanation, you can go ahead and watch the video for those. So, looking at this problem up here, based on historical data, an insurance company estimates that a particular customer has a 1.4% likelihood of having an accident in the next year, with the average insurance payout being $3,500. If the company charges this customer an annual premium of $120, what is the company's expected value of this insurance policy? So basically, we want to figure out on average, how much is the company gonna make per person? So, we go our expected value. So we kind of have to do this by outcome. There's two outcomes here. Either the person doesn't have an accident or they do, right? So if they don't have an accident, the company, remember we're thinking about this from the company's point of view, since we want the company's expected value. The company is going to gain $120, right? Because that's how much they charge. So the company would gain $120. And then we want to put the proportion for how likely that is to happen. So we have a 1.4 likelihood of having an accident. So that means not having an accident would be a 98.6% chance, right? Now we are going to change this to a decimal here. So I'm going to go 0.986. Okay, so they have a 98.6% chance of getting $120. Now we're going to go plus our second outcome. Now our second outcome is that the person has an accident. So the company, if we think about it, they would gain $120, but then they would have to pay the $3,000. So then they would lose $3,500. Okay, and the chances of this happening are the 1.4%. So we have 0.014. Okay, so this is kind of our outcome 1, outcome 2, and then we just add them together. And so you can just put that whole thing in your calculator, and we get 71, I think is what it is, yeah. Okay, so what this means is on average, the company will make $71 per person that they sign up. Okay, so like if they have, 10 people signed up, they would make $71 per person on average. So they get about $710. Okay, let's scroll down and we'll do another example. So, this one, we have tickets for a raffle, cost $19. There are 719 tickets sold. Oh, sorry, guys. One ticket will be randomly selected as the winner, and that person will win $1,500, and they're given back the cost of the ticket. So for someone who buys a ticket, so from this person's point of view, what is their expected value? So we have two outcomes again. They either win the raffle or they don't, right? So let's think about if they don't win the raffle. So the raffle costs $19, so they're going to lose $19, right? So negative 19. And then we need to find the probability that they don't get their ticket drawn. So since there's 719 and they're only drawing one ticket, it'd be 718 over 719. Okay, and you can turn that to a decimal, but I would just wait until the very end. That way you're not rounding at all until the very end. Okay, that's outcome 1, is they do not win. Second outcome is they do win. Okay, if they do win, they will get $1,500. Okay, now they did have to pay $15 or $19 for the ticket, but they also, if they win, they get their $19 back. So that's just going to even out to be 0 and back to $1,500. Okay. And now we want to look at the probability of them winning, which is 1 out of 719. Okay, and that's our setup. And then again, we just type that into the calculator. So when you type that in, you should get negative 16.89. Okay, so on average, buying one raffle ticket, you'll lose $16.89. Okay, and that's because there's not a very good chance of you winning, right? So for every ticket you buy on average, you're going to lose this much. Okay, let's look at the next one. We don't always have it doesn't always have to do with money. So there's this one on the left. Suppose there's a 20% chance of 1 inch of rain, a 70% chance of 2 inches of rain, and a 10% chance of 3 inches of rain. What is the expected value? So you don't only have to have 2 outcomes. So far in the examples we've done, we've only had 2, right? Basically you win or you don't win, or you have an accident or you don't have an accident. So this one has 3 outcomes. There's 1 inch of rain, 2 inches of rain, and 3 inches of rain. So we're finding the expected value for the amount of rain. So option 1 is we get 1 inch of rain, right? And that has a 20% chance. So we're multiplying by 0.2. Option 2 is we get 2 inches of rain. Okay, and that has a 70% chance. And then option 3 is we get 3 inches of rain, and that has a 10% chance. Okay, so the average expected amount of rain we're going to get is 1.9 inches. Okay, which kind of makes sense, right? Because we're pretty close to 2, which is the most likely. Okay, all right. I'm going to have you guys try this one on your own, a couple things before we pause the video. So you'll read through this. Make sure you're remembering you're looking at North's expected value, okay, not Kids' expected value. You're looking at what North is going to gain from this. And then the second thing I was going to tell you is something. I think I was just going to say keep it as a fraction like we did up here for this one. Okay, Mr. Montgomery is going to pause the video and you guys can try this one. Okay, so hopefully you've tried this one out. I'm just going to write it out really quick. For North, if he draws the face card, then North is going to lose $4. Okay, in a deck of 52, there are 12 face cards. Plus, North is going to gain $5 if he draws any other card. So there are 40 cards left out of 52. Okay, and when you type that in, you get $2.92. So this is a good game for North to play because on average, they're going to win $2.92 per round. Okay. All right, one last example. Looking at a raffle ticket for a charity ball, the charity is selling 2,000 tickets. One of them will be drawn, and the person holding the ticket will be given a prize worth $4,000. When someone buys a ticket, what's the expected value? So this is the expected value for the person who's buying the ticket, right? In a second, we'll do the expected value for the charity. So for the person who's buying the ticket, they have two outcomes, right? They win or they don't win. So if they do not win, they are going to lose $5. That's the cost of the ticket. And not winning has a chance of 1,999 out of 2,000. Okay, and then second outcome is that they do win. Okay, if they do win, they will have paid for the ticket, but then they're going to gain $4,000, right? This one doesn't say that they get the $5 back. So, and then the chances of them winning are 1 out of 2,000. Okay, I'm going a little quick because I know you guys are probably running short on time. Type that in your calculator, you get -$3. So basically, if you buy a ticket, at the per ticket you buy, you're probably going to lose $3 on average. Okay, expected value of the ticket to the charity. So this is kind of thinking backwards. We're thinking, what is the charity going to gain? So for every ticket that is not won, right? Every ticket that does not win, they're going to get $5. And again, that's the same 1,999 out of 2,000. Okay, plus it now on the winning ticket, they will get $5, but then they'll lose 4,000. Okay, and that's a 1 out of 2,000 chance. And if you type this in, you end up getting $3, which kind of makes sense, right? Because if a person's going to lose $3 per ticket they buy, then it makes sense that the charity is going to gain 3 tickets per charity. All right, that's it for Module 6.